Hello guys, welcome to VChem World. In this lecture, we will discuss on the all concentration terms and also relationship between the one another. First, start with the molarity. What is the meaning of the molarity? We know that the molarity is denoted by the M. This is the M. Molarity is equal to the number of moles of solute dissolved in per liter of solution. So we write that M is equal to number of moles of solute dissolved in per liter of solution means volume of solution in liter. When volume of solution used in the ml, so it's multiplied with 1000. First, we know that what is the meaning of the mole. So mole is denoted by N, and this is the weight upon molar mass. How to find the molar mass? Molar mass is the, for example, find out the molar mass of the NaCl. So NaCl, Na and Cl. When Na has a 23 and Cl has a 35.5 atomic mass. When sum of atomic mass gives the molar mass. That way we find out the molar mass of the any compound. So N is equal to W by M. We put this value in this equation. So number of moles of solute is equal to W upon M multiply with volume of solution in liter. So V, and this V is ml, so it's multiplied with 1000. That is the molarity. Then unit of the molarity. How to find out the unit of molarity? Weight and M. So this is the mole. Molarity unit is the mole per liter. Moles and volume of solution in liter. So its units mole per liter. And next factor is the temperature dependent and independent. Molarity is the temperature dependent because of the in the molarity volume. Denominator is the volume. Means the volume is changes when temperature increase. Temperature increase, volume increase, and temperature decrease, volume decrease. So this concentration of the molarity is the temperature dependent quantity. That is all about the molarity. Next term is the normality. What is the meaning of the normality? Normality is denoted by the N. Is the number of gram equivalent of solute dissolved in per liter of solution. So write that the N is equal to the number of gram equivalent of solute dissolved in per liter of solution. The same as the molarity. So volume of solution in liter. What is the meaning of the gram equivalent of solute? So gram equivalent of solute is equal to, this is the mole. So mole is equal to weight. That is the same as the weight. But in this molarity, molar mass used. But in this, the normality, equivalent mass used. How to find out the equivalent mass? In the molar mass, we know that the sum of the atomic mass, we find out the molar mass. But how to find out the equivalent mass? So equivalent mass is equal to molar mass upon N factor. Molar mass is the same as this molar mass. And N factor means that different terms. For example, valency, acid present. When acid present, so it's H plus ion, base present, so it's number of OH minus ion. Whereas the salt present, so charge of the cation present, and oxidizing and reducing agent. For example, we consider is the H2SO4. For the H2SO4, molar mass is equal to 98. And this is put in this equation 98. But this H2SO4 remove 2H plus ion. So that is the N factor is 2 because of the it's removed 2H plus ion. That means that the N factor is 2 divided by the 49. Molar mass is 98. For find out the molarity, it's used 98. But find out the normality, we use 49 because of the H2SO4. N factor has 2. That is the equivalent mass is equal to molar mass upon N factor is equal to 49. What is the unit of the normality? In the molarity, unit is a mole per liter, but normality unit is the gram equivalent per liter. Gram equivalent per liter. Then next factor is the temperature. This is the also temperature dependent because of the volume of solution is used. When volume of solution used, it is the temperature dependent. Because of the temperature increase, volume increase, and temperature decrease, volume decrease. So this is the relation between the molarity and normality. And another is the normality is equal to n factor into m. This is the relationship between the molarity and normality. Third is the formality. Formality is denoted by the F. What is the meaning of the formality? Formality is the number of 4 mole of solute dissolved in per liter of solution. So that is the number of 4 mole of solute dissolved in per liter of solution, means volume of solution in liter. What is the meaning of the 4 mole of solute? This is the mole, in this the gram equivalent solute, that is the 4 mole of solute. It's denoted by the Fn. This is the weight upon formula mass. Weight upon formula mass. How to find out the formula mass? For the any ionic solid, for example NaCl. In the molecular formula, NaCl gives the 58.5. But in this formula mass, we find out the NaCl dissociate into water. So it's converted into NaCl dissociate into water, Na plus and Cl minus. So that gives the mass. This known as the formula mass. For example, consider as the benzoic acid. This benzoic acid, in the molecular formula, we use only one benzoic acid molecular mass. That is the 122. But in this benzoic acid, in benzene, it combines together and gives the dimer form. So its dimer form and its formula mass is 244 gram per mole. That means that the 244 is the more than the 122. That is the formula mass. That way we find out the formula mass. How to find out formula mass means that any compound when dissociate into its original solution, it gives the mass. It's known as the formula mass. So Fn is equal to W upon Fm. We put this equation. So W upon Fm multiplied with volume of solution in liter. When volume is ml, so it's multiplied with 1000. So formula mass F is equal to formality. What is the unit of the formality? So unit of the formality is the gram formula mass upon liter. Formula mass upon liter. That is the main difference between the formality and molarity. In the molarity, molecular mass used, and the formality, formula mass is used. That is the relationship between the formality and molarity is formality divided by the molarity is equal to the theoretical molecular mass upon observed molecular mass. For example, consider as the benzoic acid. In the benzoic acid, theoretical we consider only one molecule. But in the practical, observed molecular mass means that in the practical, benzoic acid combined together gives the dimerization. So its observed molecular mass is 244, whereas the theoretical mass is 122. So that gives the ratio, and this ratio is known as the Van Hoff factor. Next is the temperature dependent factor. Yes, that is the temperature dependent factor. Why? Because of the volume of solution is used. When volume of solution present means temperature dependent. Temperature increase, volume increase, and temperature decrease, volume decrease. That is the normality, molarity, and formality. Next is the molality. Molality is denoted by the small m, and molarity is denoted by the capital M. This is the molarity and this is the molality. Where definition of the M is the number of moles of solute. So this is the moles of solute dissolved in per kilogram of solvent. So that is the mass of solvent in kilogram. Molarity is equal to number of moles of solute dissolved in per kilogram of solvent. In these three, we use solution, but in the molality, solvent use. We know that the solution is equal to solute plus solvent. So where we found the solvent, so solution minus solute gram, it gives the solvent. This is the kilogram. When this given is the gram, so it's multiplied with 1000. Same as the moles gives the moles. So N value is equal to same. N is equal to W by M. We write that the W by M. This is the molar mass. N. Mass of the solvent is MS. Where is in gram? So it's multiplied with 1000. So molality is equal to W into 1000 upon M into MS. Next is the temperature dependent or independent. This is the temperature independent because of the in the molality no solution was present. Means the volume of solution is absent. When volume of solution absent means temperature independent. In this only weight or mass present. So that way this is the temperature independent. Molality is the temperature independent. Next is the unit of the molality. Its unit is the moles of solute. So first is the mole and divided by the mass of solvent in kilogram. So moles per kilogram. This is the unit of the molality. Next is the mole fraction. What is the meaning of the mole fraction? For consider in this beaker two components present A and B. That is the two components A and B. We find out the mole fraction of A. Mole fraction is denoted by the chi, where this is the number of moles of component and number of moles of total. Means that we find out the mole fraction of the A. So this is the number of moles of A divided by the total of the solution. Means number of mole of A plus number of mole of B. So that is the mole fraction of A. That same way find out the mole fraction of B. This is the moles of B divided by the total numbers of moles Na plus Nb. And another, we know that the Xa plus Xb is equal to always 1. So first we find out only Xa. Then we find out the Xb because of the 1 minus Xa is equal to the Xb. That way find out the mole fraction. Next is the unit of mole fraction. This N means mole and this is the also mole. So that is the mole. Mole cancel out. So it is the unitless. Mole fraction is unitless. Next is factor is the temperature dependent or independent. This is the temperature independent. Why this is the temperature independent? Because of the in the mole. So we know that the mole is equal to weight upon molar mass. So in the mole no any volume present. Where volume is absent, that means it is the temperature independent. So mole fraction is temperature independent. Next is the percentage weight by weight, percentage weight by volume and percentage volume by volume. What is the meaning of this? So first is the percentage weight by weight means that the mass of solute divided by the mass of solution. And this is the percentage. So it's multiplied with 100. That is the percentage weight by weight. Next, percentage weight by volume. That is the mass of solute divided by the V. V means volume. So this is the volume of solution in liter and also multiply with 100. Then third is the percentage volume by volume. So this is the volume of solute divided by the volume of solution and multiply with 100. That is the percentage volume by volume. Volume of solute divided by the volume of solution. Multiply with 100. Then next factor is the what is the temperature dependent and temperature independent. Weight by weight. So this is the no volume terms present. That means this is the temperature independent. Second term is the percentage weight by volume. In the percentage weight by volume, volume term present. That means it is the temperature dependent. And third is the percentage volume by volume. So it is also temperature dependent. Next is the ppm. ppm means the parts per million. So ppm is equal to the mass of solute divided by the mass of solution multiplied with 10 raised to 6. In another meaning, mass of solute it's denoted by the weight and mass of solution it's denoted by the weight. So this is the ppm per mass or per mass. The next we find out the ppm by volume. So this is the ppm by volume, that is the volume of solute divided by the volume of solution multiplied with 10 raised to 6. So first is the ppm by mass and second is the parts per million by volume. Its unit when volume use and this is also volume use. So this known as the ppm by volume and this known as the ppm by mass. It is the temperature dependent or independent. First term is the only mass use and mass use. So this is the temperature independent. But in this ppm by volume, that is the temperature dependent because of the volume of solute and volume of solution present. So that is the temperature dependent.